Let us take the next question. It's given a car engine has a single plate clutch having outside diameter of 25 centimeter and inside diameter of 20 centimeter. If the axial load exerted by springs is 1500 Newton, determine the power transmitted by the clutch at 700 rpm. Assume uniform wear. This is the question. Whatever is given here, I'll write this in the form of data. Here it is mentioned that the clutch is single plate, so I'll write the type. Single plate clutch having outside diameter of 25 centimeter. So here I have drawn a friction plate whose outside diameter is 25 centimeter. So D1 is equal to 25 centimeter, that is 250 mm. R1 will be half of this, 125 mm. Inside diameter is 20 centimeter, so D2 200 mm. R2 comes out to be half of this, that is 100 mm. Next, if the axial load exerted by the springs is 1500 Newton, this is the first problem in which they have given the value of axial load, otherwise we were calculating this value. So axial load is equal to 1500. Determine the power transmitted by the clutch at 700 rpm. The question is, we have to find how much power is to be transmitted, and speed is given as 700 rpm. Next, they are saying that assume uniform wear. The condition, the theory which we have to assume here is of uniform wear because it is mentioned. Otherwise, if they had mentioned nothing, then also we would have used uniform wear theory. Now to calculate power, let us start with this question. Since power transmitted by shaft, or I can say power transmitted by the clutch plate, shaft is the engine shaft. Since power transmitted by single plate clutch is given by P is equal to 2 pi nt by 60. I'll give this as equation number 1. Now RPM is given in the problem, it is 700. Only unknown is torque. If I can get the value of torque, I can calculate power. Therefore, torque transmitted by single plate clutch is given by torque T is equal to N mu W Rm. I'll give this as second equation. Now I'll go for the calculation of Rm. I'll say that by uniform wear theory, Rm, that is mean radius, it's equal to R1 plus R2 divided by 2. So therefore Rm is equal to R1 is 125, R2 is 100. Therefore Rm will be 125 plus 100, that is 225 divided by 2, so that comes out to be 112.5 mm. Next, after calculating Rm, Since I know the value of W, mu and N, it is given in the question, I'll put all values in equation number 2. Put all values in equation number 2. Therefore, T is equal to N, number of effective surfaces are 2, into mu, it is given in the question. Here mu is not mentioned, so I'll assume the value. Mu, I'll take it as 0.3 into W, it is 1500 into Rm, which is 112.5. I'll write down here, assuming mu is equal to 0.3. Therefore, T value comes out to be 101.25 into 10 raised to 3 Newton mm, or 101.25 Newton meter. Once I know the value of torque, I will put all values in equation number 1 and get the answer of power. Power is 2 pi n, n is 700, into T is 101.25, so it is 2 pi nt divided by 60, and here I am getting the answer of power as 7.42 into 10 raised to 3 watts, or it is 7.42 kilowatts. That is the answer. So 7.42 kilowatts is the power which is transmitted by the clutch, and this power will be transmitted from the engine shaft to the gearbox. That is the shaft at the gearbox, it is called as a clutch shaft. So the clutch which we have here, it is capable of transmitting 7.42 kilowatts of power, and that was asked in the question. With this, we complete the question.